Hello everyone, this is Grade 3, Module 7, Lesson 21 homework. The directions state, Margot finds as many rectangles as she can with a perimeter of 7 centimeters. Shade Margot's rectangles on the grid below. Label the length and width of each rectangle. So, going with our strategy, we have 14 as our desired perimeter. I'm going to divide that by 2 because I want to break it in half. Now, I'm going to find all of the addition problems that can make 7. So I know 1 plus 6 can, 2 plus 5 can, and 3 plus 4. So those are going to be my length and width for my rectangles. So my first one is a 1 by 6. So I'm going to go out to 6 here. And there's my shading, and I'll label it with 1 and 6. My next one is going to be a 2 by 5. So I'm going to do 5 of them. And I know that that's a 1 by 5, and I got to do 2 groups of it. So now I can label that one 2 centimeters by 5 centimeters. And then my last one will be a 3 by 4. So I'm going to come out 4, which is right here. And I can come down 3. And I'll label those 3 centimeters and 4 centimeters. And I'm going to do a quick check to make sure. So 1 plus 1 plus 6 plus 6. So 2 times 1 plus 2 times 6, that's 2 plus 12, which is 14. This one is 5 times 2, because I have 2 5s, and then 2 times 2. And I get 10 plus 4, which is 14, so that's good. And my last one, I have 2 times 4 plus 2 times 3, and again, 2 groups of 3 and 2 4s. So I get 8 plus 6, which equals 14 centimeters. So everything looks good with these. So we'll take a look now. Find the areas of the rectangles in part A. And I'm going to do them by color. So my first one, I know it's length times width, so I'm going to do my numbers of 6 centimeters times 1 centimeter, and my area is 6 square centimeters. For my next rectangle, I'm doing 5 centimeters times 2 centimeters. That's going to get me 10 square centimeters. And my last one, I know that I have 4 and 3, so 4 centimeters times 3 centimeters, and that will get me 12 square centimeters. Did that kind of quick there, but you're seeing in blue 5 and 2, 5 and 2, in red 6 and 1, 6 and 1, and then in black 4 and 3, and there's my 4 and 3. Let's take a look at the next part. C says the perimeters of the rectangles are the same. What do you notice about the areas? And I think you can take that one when you see the area for one of them is here, one's here, and one's here. Make your statement within that for C, and I think answers are going to vary quite a bit on that based on what you see. So let's take a look at page 2. So over here on page 2, we have a problem that we'll take down first, and that's question 2. Tanner uses unit squares to build rectangles that have a perimeter of 18 units. He creates the chart below to record his findings. Complete Tanner's chart. You might not use all space in the chart. So what I'm going to do for this is I'm going to start by looking at my perimeter of 18, and I want to divide it by 2 to get 9. So I'm going to find all of the combinations where two numbers added together get me 9, and I see I have 1 and 8 here. So I'll start with the next one. 2 plus 7 gets me 9. 3 plus 6 gets me 9. 4 plus 5 gets me 9. And I can't go any higher than that, because if I get up to 5 plus 4, it does get me 9, but it's the same thing as this one. So I'm not going to do that because it's the same rectangle, it's just turned a different direction. So I don't want to do any repeats. So I'm going to write these in, and I'll abbreviate. And I know this because if I put a square in, or a rectangle in here, and I do 2, 2, 7, 7, 2 and 7 is 9, 7 and 2 is 9, 9 plus 9 equals 18. And that's going to be the case for each of these. If I do 3 and 6, they equal 9, they equal 9, and 9 plus 9 is 18. And then for my last one, 4 and 5 is 9, 4 and 5 is 9, and 9 plus 9 is 18. So now it's a matter of figuring out the area for my different rectangles. So I made 4. And now what I'm going to do is I'm going to multiply. I got to multiply the width and lengths together to get the area. So 1 times 8 is 8 square units. 2 times 7 is 14 square units. 3 times 6 is 18 square units. And 4 times 5 is 20 square units. So for B, I think you can take that explanation based on what we did. We took half of what we wanted to find with the perimeter and then made different addition combinations to get 9. And that's what our length and width were. So that explanation I think is going to be for you to put into your own terms. And then 3 says, Jason and Dina both drew rectangles with perimeters of 12 centimeters, but the rectangles had different areas. Explain with words, pictures, and numbers how this is possible. So I'm going to do some examples here. One for Jason, one for Dina. And the first thing I need to know is the perimeter of 12. So to find some different length and widths, I'm going to break it in half to get 6, and then find some addition problems that will get me 6. 1 plus 5, and then I'll do 2 plus 4. So Jason is going to draw a 1 by 5, and Dina is going to draw a 2 by 4. And what I'll do now is I'll show that these perimeters are 12, and then we'll look at the areas. So if I do 2 times 5, plus 2 times 1, I'll get 10 plus 2, which is 12. And then for Dina's, I have 2 times 2 plus 2 times 4, because I have 2 groups of 2's and 2 groups of 4's. And 4 plus 8 is 12. So they both check out for perimeter. But when I look at the area of it, I'm going to multiply the two sides, length and width. So 1 times 5 is 5. And then for Dina, 2 times 4 is 8. And I didn't put units in on this one. I can, just to help out. But the big question is, explain in words, pictures, and numbers how it is possible that they can both have rectangles with perimeters of 12, but they have different areas. And the way this is the case is because their side lengths are different measurements. And there's my answer statement right there. Hope this helps. Thanks for watching, and good luck on the rest of your homework.